We all love cars and use them daily. That's why we wanted to bring you closer to some car components. Core structure. First, we want to start with the automotive history. Then we'll continue with our components, which are divided into 5 topics. First, the combustion engines, then the e-motors, then the transmissions, continued with the exhaust system and the suspensions. Starting with the history of the cars. The first wheel was invented 4000 before Christ. In 1649, the first mechanical car was built. One of the biggest milestones was reached in 1804 with the first vehicle with a combustion engine. In 1839, the first electric car was invented. Carl Benz created the first planetary car in 1885. Opel started producing the first car on an assembly line in 1924. Firstly, in 1933, the automatic transmission was created, and from 1970 till today, human-built cars which are becoming increasingly safer.
After discussing some milestones of automotive history, let's come to some components of a car, like the engine, the transmission, the exhaust system, or even the suspension. First step is the petrol engine. Petrol engines differ from diesel engines in terms of ignition, because they have an external one. Like diesel engines, petrol engines are reciprocation engines. Means an up and down movement is converted into a rotation over the crankshaft. Moving on to combustion temperature for petrol engines is in the range of 400 to 600 degrees, which follows in a higher carbon dioxide pollution than diesel engines but lower nitrogen oxides. So now to the function. But how does a petrol engine work? On the picture shown here, you see the 4 strokes of an engine. First one is the intake stroke, where air with fuel or without enters the cylinder. The piston moves downward, which creates the negative pressure for the air to be sucked into the cylinder. Second step is the compression step. The piston moves back upwards and the air gets compressed up to a compression ratio of 10 or even 14 to 1. Now on to the important step. The air-fuel mixture, or in case of a direct injection, the fuel gets injected shortly before the piston reaches the upper dead point and ignites the compressed mixture shortly after. Because of the following explosion, so-called explosion, the piston moves back downwards, which is the time the piston generates torque. For the last step, the piston moves back upwards to emit the exhaust gases into the exhaust system, which we will discuss later.
Moving on to the diesel engine. The diesel engine also works on the self-ignition principle. The efficiency is here from 25 to 45%. The diesel engine is also a reciprocation engine, which has an up and down movement of the pistons, resulting into a rotation. The combustion temperature is from 700 to 900 degrees Celsius, which leads to a higher nitrogen oxide pollution. The diesel engine also have a long stroke, which leads to higher torque and lower RPMs. So, a diesel engine operates on the diesel principle, involving the following steps. Initially, air is drawn through an air filter and compressed in the cylinder. Compression occurs solely through the piston. Without prior air-fuel mixture, fuel is then injected, and due to high temperature and pressure, self-ignition of the diesel fuel occurs in the cylinder. This self-ignition drives the piston downward, creating a power by expansion stroke and generating mechanical energy. Finally, the burned gases are expelled through the exhaust. So coming now to the e-motors. The e-motors have a way higher efficiency than the petrol engine or the diesel engine. It can have a efficiency up to 90%. The e-motors are divided into 2 different motors, the asynchronous motor and the synchronous motor. Here in the top picture, you can see an electric motor divided into two main parts, the rotor and the stator. So coming now to the workings of an electric motor. At first, the rotor is unaffected and in a vertical position. No current flows through the coil, and therefore the rotor does not yet possess a magnetic field. When you apply an electric voltage, the coil generates a magnetic field, and the iron core, the rotor, becomes an electromagnet with a north and south pole. Since the rotor is rotatable, it continues to turn until the unlike poles of the two magnets from the rotor and the stator face each other and attract. This position is also called the optimal alignment. The rotor no longer rotates at this point. To keep the electromagnet continuously rotating, the magnetic orientation of the rotor must be reversed. This task is performed by a commutator connected to the coil and where the voltage source is applied. It switches the north and south poles of the rotor. Afterward, the process repeats from step 3. The asynchronous motor is an electric motor which operates through electromagnetic induction. A turning current in the stator creates a change in magnetic field, inducing eddy currents in the rotor. And the interaction of these magnetic fields generates torque, driving the rotor in a continuous rotational motion. The synchronous motor is an electric motor which operates by synchronizing the rotation speed of its rotor with the rotating magnetic field in the stator. The motor is powered by alternating current in the stator coils, generating a constant speed rotating magnetic field. The rotor, equipped with the permanent magnets or windings, aligns itself to match the speed of the stator's magnetic field, resulting into a continuous rotational motion. So coming to a comparison of those both e-motors. The first one is the operating principle. The asynchronous is working on the electromagnet induction, and the synchronous is working on the rotating magnetic field. For the starting mechanism, the asynchronous motor is self-starting, in case the synchronous one is requiring an external device. At the asynchronous motor, the speed control is influenced by the load, and the synchronous motor holds constant speed of rotation. The asynchronous has a lower efficiency due to different loads, and the synchronous has a higher efficiency when machines are demanding on constant speed. Coming to the last point, the construction. The asynchronous is cost-effective because it needs fewer components in the construction, which in the other case, the synchronous has a more complex construction and is in this case more expensive.
So we talked a lot about generating power. Now we want to talk about how to keep the engine in the best possible operating point. Consists in the simplest way of an input shaft, counter shaft, and an output shaft. With the switching sleeve, the loose gears are connected firmly with the shaft.
Coming to our next topic, the automatic transmissions. So on the top you can see a picture of the torque converter. The torque converter is a crucial component in the automatic transmission. It consists of two main parts, the pump impeller and the turbine. The pump impeller is driven by the engine, creating a rotating oil flow in the torque converter. The turbine is connected to the transmission shaft and is driven by the oil flow from the pump impeller. Coming now to the planetary gear set, which you can see at the bottom. This is a system of planetary gears that generates various gear ratios. The planetary gear set allows for multiple gears without manual intervention. The last part is the hydraulic control system. A hydraulic control system regulates the pressure in the transmission. controls the shifting process and adapts to different driving conditions.
Many people confuse this transmission with an automatic one, but it's only semi-automatic. Actually, it works like a manual one, but only has 2 clutches, 2 input and 1 output shaft. The gear changes are done by a mechatronic module. Here you can see the 2 clutches, 2 input shafts, 1 full wave and 1 around. This one also named hollow shaft. One shaft takes over the straight gears and the other uneven gears. Reverse gear can be on both shafts. The secret of a double clutch transmission is that the gears are selected by the same time while one clutch is closed and the other is not. This makes it possible to shift incredibly faster. For example, gear 1 is selected, then gear 2 on the other shaft is already selected, but with clutch open. When there's a gear change, clutch 2 closes, and if you accelerating more, clutch 1 opens and gear 3 will be selected, and so on. So you have, in every case, the next gear you want selected. This is controlled by a mechatronic. Now on to the exhaust system. Here we see where the exhaust gases come out of the motor, going into the flange, so-called flange, going through a catalytic converter, and then going through a muffler, which should do silencing, and another silencer at the end. So now on to the diesel after treatment system and the 3-way catalytic converter. So how you see, the diesel after treatment systems is mainly used for diesel cars, and the 3-way catalytic converter is used for petrol cars basically. So in the 3-way catalytic converter you have one reduction. Nitrogen oxides get reducted to nitrogen. In this reaction we have oxygen moving on to the oxidation and oxidates carbon monoxide to carbon dioxide. And also unburned fuels gets oxidated to water. In the diesel cars, you need a separate oxidation cut and a diesel particle filter and a SCR cut, which is the reduction part. That's the reason why it's also green, and this is also orange. And in this diesel after treatment systems, there are the same reactions going on, but separately. That's the reason because a diesel combustion is hotter than a petrol combustion. And therefore, there are more nitrogen oxides. And when you have more nitrogen oxides, this reaction in this 3-way catalytic converter would not happen. So you have to split it up, and then you have the same procedure. The last theme for today is the topic suspension. This is the part which absorbs bumps in the road, making the ride more comfortable and safer. I divided this part into 4 types. We have steel springs, we have coilovers, which are adjustable steel springs in height. We have air suspension, like you see on the right, where the steel spring gets replaced with the air balloon. And we have magnetic ride. Magnetic ride means adjustable dampers with magnetic particles in the oil. So next on we go to the springs. The springs absorb the shock and starts to oscillate. The damper has the task to eliminate the oscillation as fast as possible, mainly for driving safety, but also for comfort. So that the car has, in every situation, all 4 wheels on the ground. See a picture of a damper. A damper consists of a rod, of the rod with a piston and holes in it. The oil has to press through these holes, and therefore the oscillation gets dampened. Magnetic ride means only that the oil has magnetic particles in it, and you can put the current on them, and when that happens, the viscosity of the oil changes, and therefore the damping changes also. So you can change between soft damping and hard damping. This was our presentation about automotive, and we hope you've learned something. On the next slides, we have our sources. Thanks for watching.